Okay, so the first time, first thing we need to get today, tomorrow, and maybe next Monday, go through the DC circuitry. That will be the basic, okay? And it will be the handout I given to you for your guys reading, okay? Normally, we will be using my um, different computer to teach you guys anything about here. Okay, so basically you can go to the quickly go into that thing, okay? And that's just telling you that DC means the direct current and also AC alternate current. So you can find somewhere DC voltage like your car battery. That will be 12 volt, okay? That's a DC. They just a certain value, 12 volt, 5 volt, or whatever voltage, okay? However, if you're looking on the AC, that's just a sideway. They vary with the time. So if you're looking into your outlet, you can say that will be AC, 120 volt, okay? However, in your computer, they using the DC voltage. Any equipment, they using the DC voltage, okay? And also in here, they just given to you what the capacitance and stand for C, unit will be farad, and the symbol for unit will be F, and also voltage will be E and volt and V. Current will be I, ampere, okay, and A. Frequency, F, and will be unit will be a hertz, and that will be a symbol. Inductance, Henry, power will be watt, resistance R will be in ohm. Reactance will be H, also in ohm, and impedance Z, also in ohm. That's just a definition. Okay, and now we need to know about it prefix. They call it capital T, they call it tera, 10 power of 12, giga, 10 power of 9, mega, 6, kilo 3, milli, minus 3, micro, minus 6, nano, minus 10, pico, minus 12. Okay? If you can remember that, that's good. If not, then you have to open it again. Try to find out what is micro. Okay? 10 power of 6. And that will be talking about the resistor. Okay? Basically, this is a resistor. You're looking at the side of a resistor. Okay? And resistor basically just try to limit the current. Okay? They will be opposite to the current flow. If the big resistance, then less current. Okay? So they tell you the schematic symbol, letter R, unit will be O. Okay? I just quickly go through that thing. And now resistor, you get two different resistors. One they call a general purpose. They get 4 bands. Okay, 1, 2, 3, 4. And the precision, they get 5. Okay, that means 1, 2, 3, 4, 5. So when you're looking into the register, you're able to recognize is it a general purpose or precision. And this is the way how to calculate the value of the register based on the color. Okay, so the first band they get whatever number here. Okay, a second band, what color, what the number, and third band will be multiplied. Okay, by whatever number. And that will be same thing for precision. Okay, basically just talking about the power. That means the size of the resistor, how much they can be handle the power. Okay, for that small one over 8 watt or quarter watt or half watt. Okay, if you are using too much current and resistor too small, they will be burned out. Okay, and this basically you can see for the law. Okay, I just go through it quickly so we don't get here. Try to introduce to you. And now we will be go into my iPad so I can go detail everything for you guys. Okay. Okay, first thing we're talking about power tank. Okay, 10 power of 1 equal what?
10.
10. Okay, 10 power of 2.
100.
100.
That means 10 times 10,
10.
100, right? Or 10 power of 3. You can say
1000.
equal 1000. Okay, 10 power of 0.
1.
Very good. 1. 10 power of minus 1.
0.1. 0.1.
10.
Okay, that means 1 divided to 10. 0.1. Okay, and 10 minus 3. Same thing. 1 over 10 power of 3. I don't want a negative power. Okay, so that's why. So this will be equal 1 divided target. Okay, so they can be equal 0.00.
1.
Any question on that power of 10? Easy, right?
Yes.
Okay, filter. Now, if you get 3 times 10 power of 2, and you can adding to 5 times 10 power of 3. What do you think you can do?
It's 15 times 10 to the power of 5.
No.
No?
5200.
Okay, now how can we do?
You gotta change the powers.
Okay,
Oh, change the power match.
like the same power, right? Either way you want to do. You want to bring it up, power of 3, or you want to bring it down, power of 2. If I want this to be power of 2, that means you have to get 50 times 10 power of 2. Then you can add in 3 and 50. That's how to add in the power. And if you're doing a subtraction, the power for the two numbers, you have to make the same thing. Have to make the same power. Okay? Then you can subtract it. And then if you get the number 6 times 10, okay, power of 2 times 2 power of 3. How can we do?
All by
12.
power of 5.
Okay, in order to do it, you multiply 6 to 2. Okay? That means you get 12. And the power will be add them up. 10 power of 2 plus 3. This is just basically we bring it up to make sure we will be using in the program.
Yeah.
That's a minimum thing we need to know. If you get a question or anything, just go ahead and ask it. Okay? Then I can get another.
Hi. So I didn't understand the first one. So how did you get the 50 by 10
That means you go
at 2?
4 by 10. Go
You mean
3
what?
to 2. Then you multiply 5 by 10.
Okay. 50. Okay. 53. Okay. Okay. Thank you.
Now, on the second one here, any question for multiply here? Yeah, anything you confusing, just to bring it up. We never coming back for this thing. Okay, if it's not, I get a 8 times 10 power 5. Divide 2 10 power of 2. What you get?
4 by 10 over 3. Then
Okay.
power of 3.
You take 8 divide 2, you get 4. Okay? And times 10 power of 5 minus 2. So the answer will be 4 times 10 power of 3. You get that?
Yes, sir.
Mm-hmm.
Very good. So that's a very, very basic, okay? Okay, so you understand we can get a voltage. You can get a current. Or resistor. And the unit, they can be volt, millivolt, kilovolt. Current, the same thing. They can be ampere. They can be milliamp or microamp or kiloamp. Okay, normally you have to deal with, if I get 5 ampere, A mean ampere. I want to know equal how many in milliamp.
5,000.
5,000. That means you understand it. Milli will be 10 minus
6.
3.
Again, 3.
That means milli. Okay. Ampere will be 10 milliamp of 3,000.
Sorry, are you saying amps?
Amp will be basically greater than milliamp by 1,000. So when you see milli here, minus 3, okay? But depend on what you call compare with, okay? You compare with the ampere. Ampere basic unit, they will be equal 5,000. That means now they will be equal 10 power of 3. The thing is ampere higher than milli by 1,000. Now, another one. I get 2 milliampere. I want to know how many micro ampere. If I get 2 milliamp, I want to know how many equivalent of for micro.
2000.
2000.
Okay. You understand a micro 10 minus 6. That's what you have to remember. Milli is 10 minus 3. So basically, milli will be higher than micro by 1000. Okay? So that's why they will be equal 2 times 10 power of 3 micro. Or they will be 2000 microamp. That means you're going to going from one unit to the other unit. Okay, one more. I get 1.5 kilo ohm. I want to know how many ohm.
1500.
Very good. The thing is, kilo is 10 power of 3. That means 1000. So if you want to know, you take 1.5 times 1000. So that given to you 1500. The thing is resistance, they get a minimum ohm, basic unit ohm. And they get kilo mega ohm. They don't have a milli ohm. They don't have a micro ohm. So that is converting from one unit to the other. Technician have to get along with that. That's really neat. The thing is you have to use it all the time. And now we're talking about resistor. Okay, this is R stands for resistor. And basically the definition, a resistor will be opposite the current flow. That means if you get a current flow through the resistor, current I. Okay, if the resistor is really big, current will be small. Okay, if resistor small, then the current will be bigger. Okay, why do we need the resistor in electronic? Why?
So you don't blow stuff up?
Not quite.
To limit the current.
Exactly. They will be just trying to limit the current to the circuitry. Why? The thing is when you get a circuit board, normally they get a power, they get a one power, maybe 15 volt, 5 volt, with a certain current. For example, 2 ampere go into the circuitry. However, inside the circuitry, different part of the circuit, they need a different current. So that's why they need a resistor so they limit the current. Okay? And for the resistor, they get the 4 band and 5 band. Okay, this is the first band, this is the second band. This will be for multiply, and this will be for the tolerance. So by looking into the color, you're able to tell what is the value of the resistor. So in the interview I given you this resistor here, okay? And the first question I will be asking you, what is the value of the resistor? Now, how can you say?
Looking at the band's color code.
Okay, exactly. You can say looking into the color band, and you can telling, okay, this is 100 ohm, for example. Is it okay? By looking into the color code, we'll teach you how to do it, okay? But you can say, okay, that will be 100 ohm. But normally, this will be for assembler, not for the technician. Okay? Now, I can give it to you. If this resistor look like that one here, what's the value?
You need to tell us the color on that resistor, don't you?
If you're looking into the color, you can get a value 100 ohm. However, the problem is they open inside.
Oh, it's infinite.
They open right here. I redraw that. I'll make sure. Okay. So they open. So if you, by looking into the color, you get the right value with the color, but the resistor is not the right value. The thing is, when they open, the resistor will be equal infinity ohm. Okay? Infinity ohm, that means too big. Current cannot flow through it. Very simple thing. When you turn on your headlight, if they not on, guarantee resistance inside they be open. So the current cannot flow it. Okay? So now go back into the question. They given you resistor and they want you to tell what the value. The right answer will be, okay, you want to know the value by the color code, or you want to know the real, exactly the value of the resistor. Okay? If they say the color code, you can talking about color code. Otherwise, you will be saying, I need DMM. You know what DMM? Digital multi meter. That means the meter using to measure the voltage, measure the current, measure the resistance. Okay, and you can connect it to the resistor here, and you can tell the value. If they open, that means infinity ohm. Otherwise, they're telling you the value. That is the job of the technician. You will be using the meter. Okay? After you get through it, then you detail on the DMN. What you need to do when you're using the meter. Okay? So, this is a resistor here. You can identify by the color code. Okay? So, we'll be show you somehow enough to measure that, but we not really important thing. Okay, to know right at this time. Okay, now we're talking about the circuitry. You get the two basic circuitry. That means AC series. Okay, now you can get the circuitry this way.
Series.
40 negative 10 volt. This R1, R2, R3. Point A here, point B here, point B. And this will be route. Now, first thing, try to identify something. In this circuitry, how many resistors?
3.
3.
3. Okay. That will be 10 ohm. That will be 40. That will be 50. 10 ohm, 40 ohm, 50 ohm.
De tanto de que camino.
What is it here?
That's the ground.
Yeah. I'm muted. If you want to talk, turn on your microphone. Okay, that's what we call a common. That's also a route. That is 0 volt. Okay? Any circuitry, they will be get a common at the route. Or basically 0 volt. Like you see on your car battery. You see one red one, that's for 12 volt. And the black one, that's for common. That's for route. Okay? So we're talking about series circuit. Okay, in this way, you can get a current going from positive high. Okay, so the current going from positive go around, going back to the negative. Now I get a little explain about the current. Positive here, negative here. The current sometimes you see The textbook they draw this way. High. Going from a negative to the positive. However, we using the current going from positive to the negative. What a difference.
Electron flow is the actual flow of electrons.
Right? Exactly. The reason you get a current, the thing is electron inside material, they moving. Okay? When they moving, that is you get a current. So that's why when you say they draw from the negative to the positive, that is just a one current. We going from positive to the negative. That's what they call a conventional current. Okay, this is electron current.
Because it's picking it up.
And normally we deal with a conventional current. So you don't care about that thing. I bring it up so when you look reading on the textbook, you see they draw different. Basically, they just opposite. Okay? That means the current will be using conventional current. Okay? Make sure if you get any question, then just let me know.
The digital multimeter reads it as conventional current too, correct?
Exactly. They're using a conventional. They're not going to electron current. Okay, now when you're looking into the circuitry, how do we know this is a series circuitry or parallel circuit?
There's only one path for the electrons to flow, so it's a series circuit.
That means they get only one current flowing through R1, then R2, then R3, and so on. That means they get the same current, then they be in series. That's only easy way to recognize. Okay? If you see the current flowing through R1, R2, R3, okay? That means only one current. They in series connection. Okay. Next question A. Okay, the next will be when the current going in, you get that will be positive. When they leave it, they will be negative. Okay? They coming in, they positive. They coming out, they negative. Coming in, coming out. Okay? So, you get the interval. I given you resistor here. I can ask you, telling me which side is positive or negative.
Battery positive. The resistance side will be positive.
You say positive here?
Here the battery is positive. That side resistance is positive.
Now I given you resistor in hand. I asking you, then you telling me on left side or right side.
Left side.
Resistors don't have polarity, no? You
Perfect.
No polarity.
You have to understand that the basic. Resistor itself, they have no polarity. Remember, no polarity. Okay? However, when they connect into the circuitry, you get a current. If I coming positive, I leaving negative. You can say that a different. Okay? So normally for the series circuitry, the question first thing they want to asking, okay, what is the total resistance in the circuit?
100 ohms.
Okay? So the
Is the
question
sum of the
number
is
one,
the sum of the resistors.
exactly, total resistance. So R total equal R1 plus R2 plus R3 plus Rn. Do you understand what that means for Rn?
The
Yes.
number of resistors in the circuit. In
That
the series
means
circuit.
no matter what, how many more resistors in the circuit, keep add them up. Okay? For this problem here, so R total equal, okay, they will be equal 10, 50, 100 ohm. You add them up, you get 100 ohm. You get that?
Yes.
That's easy. The other thing, you understand Ohm law.
Yes.
Ohm law, that means the relation between the voltage, the current, and the resistor. So they can be V equal I times R. In this formula, I must be in volt. I have to be in ampere. And I have to be in ohm. If you want to using that formula, then the unit must be that way. Cannot change it. Okay? And from this formula, you can go into the other formula here. I say I want I. Then you can take V divide to R. Or I want R. Then you can take V divide to I. So those three formula, they call Ohm law. Okay?
Mm-hmm.
Now, voltage. By definition, that's a potential. Potential difference. If you get a VAB, that means the voltage from A to B. By basic definition, they have to be VA minus VB. Okay? That means the voltage at the point A will be higher than the voltage at the point B. Okay? So if you want to get a voltage from VR what? That means the voltage from here, VR1 to B, okay, from A to B. That means VAB equivalent with the voltage VR1. When we say VR1, what that means?
The voltage dropped
V-
across
V
the
what?
first resistor.
VR1, what that means? That means the
Voltage drop across resistor 1.
VR1 means voltage drop. Through R1. Okay. And now I can redraw that, try to explain to you. You can get the R1 here. That A here, B here. So VR1, that means the voltage drop here. That means the voltage from A to B. Okay? So if you get a 10 volt here, when you measure the voltage here, okay, if you also you would suppose to get any voltage less than 10. Okay, the thing is, when the current flows through the resistor, okay, if you touch the resistor, you touch the resistor, you feel hot, okay? So basically, electrical will be converting into the heat, okay? So that's why they drop the voltage. So when you measure at B here, they supposed to be 7 volt, 5 volt, whatever, but they cannot be equal 10 or higher, okay? If you turn on your headlight car, if you touch it, you feel hot, okay? The thing is electrical converting into the heat.
But in that circuit, point B attaches to ground, so point B would be 0 volts anyway, right?
Exactly. We will be go detail on that thing. You can see I can get all the calculation for you almost a time out, man. Okay, R1, R2, R3, plus, minus, 10 volt. Okay, they can be 10, 40, 50. And that point A here, B here, and that will be C. Okay, now, again, if you want to calculate the total, okay, R total, they will be
100.
That's 100.
10 plus 40 plus 50 under all. If you want to calculate the current I, you using the Ohm law, you can take V divide to R total.
0.01.
Yeah, you can get V equal 10 volt divide 100 ohm, and given you
100 milliamps.
0.1, right? Ampere. Also, I want to know milliamp. How many milliamp?
100.
0.01.
100
Well, yeah, 100.
milliamp. Okay. Now, if I want to calculate the voltage drop across R1, VR1, you must be using Ohm law. That means I times R. What R?
10.
They have to be R1. Okay? When you're using the formula Ohm law,
1 volt.
I times R have to be which R? Okay? So you can get 0.1 times 10, right? Is it a 1 amp
1 volt.
Mhm.
or 1 volt? Okay? And now if you want to calculate the VR2,
4 volts.
then I times R2, 0.1 times 40. That's 4, right?
4 volts.
And VR3, I times R3 will be 0.1 times 5, right?
Mhm.
So
5 volts.
5 volt. Okay, now the total power will be voltage will be 10 volt. When the volt current coming out, you're using voltage at R1, R2, R3. You add them up, they must be equal the total voltage. That's telling you VR1 adding to VR2 adding to VR3. They must be equal 10 volt. That means this one you can say E, okay? That must be equal E, okay? If you not, when you add them up, they not equal 10, some problem. You can be get lot power somewhere, okay? So basically, all of the power using for the circuitry, when you're adding up, they must be the same voltage. Okay, total voltage. Okay. So now, if you want to measure the voltage, okay, I'm talking about measure. Okay, is the M. So if I want to measure the voltage at point A, how do we connect the DMF? DMF high side connect to where? Point A. Okay?
You just have to put the positive side in A and the negative side in
That's what I call
B.
high mean positive, high side of the meter. tomorrow we'll be showing you the meter and also the low to where?
Ground.
Ground.
Very good. Now that technician must know. Okay, I given you the meter. I asking you. Okay, go ahead and get measure voltage at point A. Then this is the way you connect. Okay. Second thing, I want to measure across R2. Okay. Then DMM connection. High side connect where?
Point B.
Point B.
Perfect. Low
Low,
side.
low side at point C.
Point C.
Two. Point C. Okay. That is telling you when you measure at a single point, then the other side of the meter must be go to common. Okay. If I want measure V at point B, that means right here. Then the DMM high side connect to B, and the low side must connect to common. Okay. If I say I want to measure voltage here across R2, then high side will be go to B, and the low side will be go to C. Okay. So basically, on this semester, okay, I adding a few things. Okay, I can stop sharing on this thing, first thing, okay? The thing that we done our time. Just a minute. If you already been here last semester, and if you try to look into this file here, okay, on the this one will be a file for review. Okay, I just quickly go to here. I don't care, you have to go to it. Okay, after tomorrow, then you're able to do. However, this time we bring it more thing. You see that? That's what I call a network theorem. That means you're using a superposition to solving on the circuitry with two or more source. Okay. Then also, okay, we get another one they call a Thevenin theory. That means they're using the Thevenin to solving the DC circuit. Okay. If you already been here last semester, you can get easy to get through the other thing, but go to that part will be a problem. Okay. So every semester we get a different thing. Okay, for you guys, and make sure tomorrow
Okay.
when you get into the Zoom, you must using your first and the last name. Otherwise, I block you. Okay, and also um, no more register for the program. That means the anyone want to register, and the other people have to let me know. Okay, um, I will allow or not. But the thing is, right now we get too much student, over 100 students. Okay, so any question in this program? The thing is, some people asking me this way: what this program teaching for technician? Is it for a production or for the reward? Okay, that's not a quite good question. Why? The thing is, inside the company, okay, in the production area, that means they get a assembler, they get a technician, okay, and technician will be divided into test operator and reward technician, okay. We're not talking about assembler. We're talking about test operator first. Test operator means you just plug the circuit board into the system and run. If they pass, you put on the left. If they fail, you put on the right. That's a very easy job. However, that you understand easy to get laid off. The thing is not require any skill. However, after the board is not working, they will be given to another technician they call a rework. That means they have to fix the problem to make it work. Okay, that requires understanding, requires troubleshooting technique in order to fix the problem. Okay, so basically, this electronic program teaching you to be a repair, okay, rework technician. Okay, not teach you to be a test operator, not teach you to be assembler. Okay, and you want the job will be paid more, and also the job more skill, then you have to be repair or rework technician. Okay, so that's why I want to emphasize to you. This program will teach you how to fix the problem in electronics. Okay, so it's not really easy program. Require you to understand it. Okay, I find the best way in order to make sure everyone still want to be a technician, able to understand. Okay, I don't care you in Zoom or not, but really care what you have to upload on up assignment given to you in the web. Okay, we count by that in order to evaluate, how you guys do it. And if you get a problem, individual or a group of the student, you can take from me. You want to online, I will online with you. Okay, try to help you to understand in order to continuing in the program. Tomorrow we'll be talking more in this program. Today, too much thing going on. Only thing is, what is any more question?
So I don't know how often are going to be the classes, like Tuesdays and Wednesdays.
You mean how open?
How often? I mean, every day, or what time is going to be the classes?
Oh, okay. If you're looking on the web, okay, I can share to you quickly. Otherwise, now it's still
So it says
two-
Monday, Thursday, and Wednesday, right?
yeah,
Monday, Tuesday, Wednesday, Thursday, 5 to 7.
yeah. If you're looking on into the web, okay,
Okay.
then see, um,
Oh my goodness, I can't find it. So I have to go into my portal in order to see the schedule of the classes, or
no. Just a minute. I can.
courses.
It's Monday through Thursday, 5 to 7.
To get to the web, you type in electronicstech.com.
It's on the
Yeah,
home
I'm in
tab.
there.
It's on the home tab.
Okay.
So you'll see the class meeting schedule. I'll say that.
Yeah, I told you quickly.
Mr. Pham, as far as the assignments go, do you want them finished the day that we're doing them or at the end of the week?
I don't care for
Okay.
now.
Okay.
What really I care is you must be doing it sooner or later.
Sure.
The thing is, sometimes the people can do, sometimes need to take a time. Okay? Only thing is, you really want to be a technician, we help you. So basically, you know how to go to this website. Okay? If you don't know, try to get along with the website. In here, every week, I will be lead Monday what you doing. Tuesday, Wednesday, Thursday. No thing happen on Friday. Okay? No class on Friday.
So
And
3 days a week, basically.
yeah,
What time?
It'll be 4 days a week, Monday through Thursday.
right,
Monday
exactly.
to Thursday.
And now, if you look in here, you can see this is the class here. You see that? This inside the class. Okay? This will be the lab. Okay? They doing the lab. And all the equipment. Okay? We need. So if you're looking in here, take one assignment. Get 1, 2, 3. Okay? You can download, you do it. It part, okay, then you can upload as much as you can. Okay? That is just a one day, too much confusing. But for a while, should be okay. Any more questions?
Yes. By the way, I need to know what your account on the YouTube that you upload this video.
Right. We're glad you guys know.
Yeah, I
That means
sometimes
every meeting we record it. Okay? If you're missing the Zoom, you can go to the YouTube, right?
yeah, but I cannot looking for your video.
Okay, I understand. We'll make it. I already did, but you don't know. However, I will combine with Mr. Thai Zoom and will be lit on the web. You click it, you can go to that. No big deal.
Yeah, thank you.
I have a question. Is this class Tech 1 and Tech 2 together in one?
Oh, okay. Now, from next week, electronic will be Monday, Tuesday. And Wednesday will be digital for Tech 2. Tech 1 will be Wednesday on the other Zoom. They teach you about lab, simulation, review, whatever I did in this program. Okay? And by the way, I would let you guys know, in this program, I am the program header. I running this program from 1985 up to today, 35 years. Under my, I get 3 lab instructor, okay, and also 1 assistant to support the program, okay? So, look like we over student too much, so that's why I need to talk to the lab instructor and the assistant. We stop register, okay? No more, cannot handle it. Okay, if you don't have any more questions, I can stop now and we will see you tomorrow.
Quick question,
Same
Mr.
time.
Yeah.
Quick question. I know this is Lowell, Mr. Pham. Hello. I noticed registering. It said Tuan Lee is instructor. Is that's still correct, right? Or you're instructor for the classes? Are you gonna switch?
Now the thing is, inside this program, you understand the main thing is my given a lecture for 1 and 2. Okay? The other instructor just support the program. Okay? They don't have to teach. They have to do something else for me, for the program running. Sometimes I let them talking, sometimes no. When the class open, that means those people will be in the lab, not no more in the Zoom. You only see me in the Zoom. The thing is, lab instructor, they will be working in the lab with your guy. You can see like Mr. Hung Pham, okay, he working, but it's not so. Only Mr. Thai and me. Mr. Thai will be take care for the lab part. The thing is, all of the money we spend to buy the equipment for him to do. Okay? For now, at least we on 100% online.
Hey, Mr. Pham, not to beat a dead dog to death, but basically Monday through Thursday, everybody just sign in, right?
Right. But the thing is, Monday, Tuesday, for Tech 1. With me.
Make sure they sign in with their name and not their.
Yeah, make sure they have to say the name, first name, last name. You don't using number like 1, 2, 3. I'm not allowed you to get into this software. It's you. Okay? So I want to know who will be in the Zoom. What else?
Quick question. Can you hear me?
Yeah.
Oh, okay, good. Because I wasn't sure my microphone was working or not. Sorry. Thanks for the first class. There is a potential, I guess, assignment here now that says upload assignment 01, right? It says 9/8. Are we supposed to finish this off by tonight, or it's just assigned today? It's an Excel spreadsheet that still says failed.
It's assigned here. I given to you. That aside, I
Okay.
just downloaded. You can see that one, right?
Yeah.
Okay.
Yeah,
But
I just
I'm not
downloaded.
telling you what day will be the last day. You see
Okay.
that?
Yeah.
I'm just telling you if you see a status here part,
Oh,
no,
okay.
upload it. Okay?
Okay. Okay. And one question on that Excel spreadsheet is the pink zone, the pink, like the first one is K14. Is that where we enter the answer or the where it says your choice, the box, long box above?
No, right here. It's like, you know, adding number here and here. I say number B is right. I B.
Okay. Thank you.
Okay?
Yep.
Mr. Pham, should we show
Thank
them
you.
how to upload the file when they're done?
Yeah, will tomorrow.
Okay.
We'll take everyone. Now we modify. Okay? We modify take one, upload on take one. Take two, upload on take two. So that's why we're able to control. Okay? Otherwise, too many students, we cannot control. Okay? So you on take two, you will be upload on take two. Okay?
Oh,
And also,
I'm assuming I'm on take 1, not take 2, correct?
yeah, if you take one, you
Okay.
upload on take one.
Okay.
Tomorrow, I will be given the list of the students on take two. If you're not on take two, must be on take one. The thing is, the people already get through the last summer. They will be go to take two.
Okay.
Okay? That means they already learn AC and electronic. So now they can go. Okay? So tomorrow we'll get a list for you. Tonight I have to combine, okay, all of the class into my file so I know who will be take one or take two. Okay? So, what else? Otherwise,
Thank you. Bye bye.
good night. Okay?
Thank you.
Yeah,
Thank you.
good night.